Now let's construct a rational function whose only asymptotes are y equals 0, x equals 5, and x equals negative 2, and also that has an x-intercept of 1, 0, and a y-intercept of 0, 1/10. Okay, that's a lot of information. Let's try to break it down piece by piece. The fact that we have a horizontal asymptote at y equals 0 tells me that the limit as x approaches positive or negative infinity of our function is going to be 0. Okay, maybe that's going to come in handy later, but it's probably not a great place to start. How about this asymptote right here? X equals 5 is a vertical asymptote, and that tells us that we need to have a factor of x minus 5 in our denominator. The same thing is true for this vertical asymptote, x equals negative 2. We need to have a factor of x plus 2 in our denominator. Okay, maybe this is a good place to start, because we can actually start constructing a function based on that. Let's just leave our numerator blank for a second, and let's say that we know that we need to have in our denominator an x plus 2 and an x minus 5. Now, luckily for us, this function already satisfies the condition that the limit as x approaches positive or negative infinity equals 0. You'll notice if you try to plug in a really big x value, your denominator gets big, while the numerator stays at 1. So we have already satisfied the condition here that we have a horizontal asymptote at y equals 0. So our asymptotes are good. How do we get an x-intercept of 1, 0 on a function? Now you might have to go back and review x-intercepts a little bit, but x-intercepts happen where a function value or a y value is 0. And a function equals 0 when its numerator equals 0. So what does that mean for us? Think about it for a minute, but this means that we're going to need a factor of x minus 1 in our numerator. Let's plug that in here, and now maybe it's a little bit easier to see that if we plug in an x value of 1 right here, we're going to get 0 in the numerator. We're going to get something that's not 0 in the denominator, so that will give us a y value or a function value of 0. Now by changing the numerator, we may have impacted this horizontal asymptote, but you'll notice hopefully pretty quickly if you FOIL out the denominator that you still have a function with a higher degree polynomial in the denominator. So as x gets really, really big, the denominator is going to infinity much faster than the numerator. So the limit of this function will actually still be 0. Okay, how about this x-intercept is 0, 1/10? Well, maybe there's a slightly more mathematical way to do this, and I think we'll do this in the next problem. But you can just notice that if we plug in x equals 0, that's this x equals 0 right here, into this function, we're going to get 0 minus 1 over 0 minus 0 minus 10, and that magically gives us 1/10. So this condition is kind of automatically satisfied based on what we've already done. So they went easy on us on this problem. We have created a function based solely on our knowledge of the asymptotes and the intercepts. And it looks like this right here, or if you have it factored, it looks like that right there.